to Tennessee's at-home learning series for math. Today's lesson is for all fifth graders out there, though all children are welcome to tune in. This lesson is the fourth in our series. My name is Miss Williamson and I'm a fifth grade teacher in Tennessee's schools. I am so excited to be your teacher for this lesson. Welcome to my virtual classroom. Today we'll be subtracting fractions with unlike units or denominators using the strategy of creating equivalent fractions. If you didn't see the previous lesson, you can find it on www.tn.gov/education. You can still tune in today's lesson if you haven't seen the others, but it might be more fun if you go back and watch those first, as we will be using what we have learned from those lessons in today's lesson. You're going to need the lesson packet for lesson 4, or if you don't have that, you can use paper, pencil, and something to write on. I will give you a moment to get your materials collected. We have been adding fractions. Today we are going to talk about subtracting fractions. This process is very similar, so let's make sure that you have your paper ready to go so that we can begin. Let's recall that in order to add fractions with unlike denominators, the bottom number, and the fraction, we must first create an equivalent fraction so that our denominators are the same. This is also true for subtraction. We can use a rectangle model to subtract. Are you ready to get started? We're going to start with the problem 1/2 minus 1/3. Write that problem on your paper. You notice that the denominators are different. Just like with addition, that means I cannot solve these problems the way they currently are. I'm going to have to find equivalent fractions. So let's start by modeling those numbers. Let's start with 1/2. Remember, the denominator tells me that there are 2 pieces in the whole. So I'm going to cut my whole in half. And I'm going to shade in one of those, 1 out of the 2. For thirds, I'm going to partition my whole into 3 and shade in 1 of the 3. Now, what could we do to get equal units? One thing we can do is, like we did before, is I can take my 1/2 and split it into 3 to get 6, and I can take my third and split it into half to get 6. Now, do we have equal size units? Yes, we do. They are now in 6. So what would I say about 1/2? 1/2 is equivalent to what? 3/6. What about 1/3? 1/3 is equivalent to 2/6. Now that we have a common denominator, I can subtract these problems. Now here's what's different. This is new. When we added fractions, we put them together. Just like subtracting whole numbers, we're going to take apart. We're going to remove. When we model removing subtraction, we either erase or X. So I had 3/6. I want to take away 2/6, so I can either X those out to show they're gone, or if I wanted to, I could erase them, leaving me with how much? 1/6. So we could say that 1/2 minus 1/3 equals 1/6 because we found the equivalent fraction 3/6 minus 2/6. Remember, just like adding, I had to get a common denominator before I solved. I also, instead of adding the numerators, I subtract them, and the denominator stayed the same. Now, let's try another one. Write on your paper 1/3 minus 1/4. 1/3 minus 1/4. Do we have like units? No, we don't. We have thirds and fourths. So let's do exactly like we did when we were adding. The first thing we did was we modeled that. Let's model 1/3 with our lines or our units going horizontally. Let's model 1/4 with our lines or our units going vertically or up and down. For 1/3, how many need to be shaded in? 1 out of the 3. For 1/4, we need to shade in 1 out of the 4. Take a moment of private think time. How do you think we could get a common unit for these fractions? We could use the thirds and partition them into 4. I can do the 4 and partition it into 3. And now they're in what unit? Both fractions are in ninths, 12ths. I did something wrong here. Let's see, 1/3. Oh, I partitioned it 3 times when I needed to partition it 4. I apologize. So now they are in 12ths. So 1/3 would be 1, 2, 3, 4 out of 12. 1, 2, 3, 3 out of 12. Remember, we solved this the same way we do addition, except instead of adding our numerators, we subtract our numerators. 4/12 minus 3/12 equals 1/12. I can also model the subtraction on the model by taking away how many pieces? 3. 1, 2, 3, leaving me with 1/12. Ready for another one? You're going to try this one first on your own. I'm going to give you some time to work it, and then we'll go over it together. Are you ready? The problem I want you to solve is 2/3 minus 1/4. 2/3 minus 1/4. So remember, I want to start by modeling both of these numbers. I'm going to model thirds horizontally, side to side, and I'm going to model fourths vertically, or up and down. So let's start with our rectangle. 2/3. How many pieces did you partition your rectangle into? Did you partition it into 3 pieces because our denominator is 3? 1, 2, 3. How many did you shade in to represent 2/3? Did you shade in 2? Great job. 2 out of 3. What about 1/4? You partitioned your whole into how many pieces? 4, because the denominator was 4. 1, 2, 3, 4, and you would shade in how many? 1 out of the 4. Now we recall from the lessons we've covered thus far, I cannot subtract these because I don't have equal sized pieces. These pieces are slightly larger than these pieces. So in order to solve, I need to have a common unit. What do you think you could do to get a common unit? Did you say partition it? We can partition it. If I partition 2/3 and I cut it into 4 times, or 3 extra cuts to make 4 spaces, and I partition a 4th and I cut it into 3 equal sections, the opposite direction, both of my numbers are now represented with how many units? 12. So 2/3, below your model, I want you to write the equivalent, if you haven't done so, the equivalent fraction for those. 2/3 is equivalent to 1, 2, 3, 4, 5, 6, 7, 8 twelfths. 1/4 is equivalent to 3 twelfths. Now that we have a common denominator or a common unit, we can subtract. 8 twelfths, take away 3 twelfths, equals 5 twelfths. Remember, we can also do that on our model. I could take away 3 of the 12ths by Xing it out, or I could do it by erasing. So I'm going to box in our final answer, or our difference, and that is 5 out of how many? 12. So 2/3 minus 1/4 is the same as 8 twelfths minus 3 twelfths, which gives us a difference of, what did we say? 5 twelfths. Is that the only way we can solve subtraction? Remember, we discussed another strategy that we can use to find common denominators. We discussed using multiplication, but remember, if you're going to use the multiplication strategy to find an equivalent fraction, you must multiply the numerator and the denominator both by the same number, or your fraction will not stay equivalent. Let's do that strategy using this same problem. If I have 2/3, if I have 2/3 minus 1/4, using our model, we already said that we can partition both of those into twelfths. So what would I multiply by 3 to make it twelfths? Did you say 4? Remember though, what we do to the top, our numerator, we must also do to our denominator to keep it equivalent. Let's check it. 2 times 4 is 8. 3 times 4 is 12. Does that match what we got when we did our model? Yes, it does. What about fourths? What can I do to fourths to make them twelfths? I can multiply them by 3. And so 1 times 3 is 3. 4 times 3 is 12. Whether I use the model or I use the multiplication strategy, I came up with the equivalent fractions 8 twelfths and 3 twelfths. Let's try that again with another problem. This time, let's do 2/3 minus 1/4. Very similar. Oh, no, that's the one we already did. Let's do 4/5 minus 7/10. I'm going to give you a moment to try to solve that problem independently. You use what strategy works for you, whether that's drawing a model or using a number line or using that multiplication strategy that we just reviewed. I want you to notice that I started this time with 2 different sets of models because I'm going to show you something that some of you may or may not have picked up on. So if you decided to use a model, the first thing you would have done is you would have modeled 4/5. You would have taken your whole and cut it into how many pieces? Yes, 5. So I'm going to partition my model into 5 equal pieces, and I'm going to shade in 4 of those. That is 4 out of 5, or 4/5. Now on my second one, we're going to partition into how many pieces? 10 pieces. So these are going to be a little bit smaller. I'm making more cuts, which means the size of my pieces are going to get smaller. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. Remember, like I said a few lessons ago, I always tell my students, you make 1 less cut than the number of pieces. So if I needed 10 pieces, I made 9 cuts. And I just always double check myself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. How many of those do I need to shade in? 7 out of 10. Good job. 7 out of 10. 1, 2, 3, 4, 5, 6, 7. Okay? Some of you may have wanted to do the strategy we did in the past. So 4/5, 1, 2, 3, 4, and 7/10. So 1, 2, 3, 4, 5, 6, 7. Beautiful. So I could absolutely cut this into 10 and get 50 pieces. And then I could take my 10 and cut them into 5 and get 50 pieces and represent my fraction as 40/50 minus 35/50. Those are equivalent. But there's another strategy we can use. Did you recognize that I could multiply 2 by 5 and get 10? Well, remember in our first lesson, when we multiplied by 2, that was like taking each of our sections and cutting it into 2. Let's see what happens. 1. When I take each of my fifths and I cut them in half, that changes it to tenths. And so essentially what we did is what we discussed in lesson 1, where I multiplied the numerator and the denominator by the same number to create an equivalent fraction of 8/10. Do I need to change the 7/10? No. Now that I'm in tenths, these are in tenths and this is in tenths. 8/10 minus 7/10. We have a common unit. Now I'm ready to solve. 8/10 take away 7/10 is 1/10. Remember, we could also model that by Xing out. I want to take, I have 8. I want to take away 7 of those. I could do them individually, or I can do them as a whole, but just be careful, attention to precision. You don't want to make a mistake and accidentally mark out 6 instead of 7, leaving us with 1/8. All right, we have time for one more. Once again, I want you to solve it on your own first. You can use whatever strategy you want. If you want to use the rectangular array where you decompose using the other denominator, that is fine. But keep in mind that that can make our denominators big, and sometimes that makes for confusing numbers. So keep in mind, because the next problem is very similar to this one. We noticed that if I multiplied 5 by 2, I could get an equivalent fraction with a denominator of 10. So keep that in mind. Your last practice problem is going to be 5/6 minus 1/2. 5/6 minus 1/2. time to do that, and if you'll notice, I was getting my board ready. I did, once again, is I drew 2 sets of 5, 6 minus 1/2. Once again, you'll notice that I shaded in 5 out of 6 and then 1 out of 2. On this side, same thing because it represents this expression. Okay, so in our first strategy, we talked about using this denominator. I'm going to take my 6, I'm going to cut them in half. I'm going to take my half and I'm going to cut them horizontally into 6 to create equivalent pieces. When I do it this way, I end up with 2, 4, 6, 8, 10, 12 pieces. So 5, 6 would be what? Equivalent to what fraction with the denominator? It would be equivalent to 10 twelfths. 1/2 would be equivalent to 6 twelfths. So my question to you is, could I solve that now that we're both in twelfths? The answer is yes, because we have a common unit. 10 twelfths minus 6 twelfths is 4 twelfths. Remember, I can model that by marking out 6 of the 12. This is what I have. This is what I'm taking away. I'm taking away 1, 2, 3, 4, 5, 6. 6 of the 12. Okay? On this side, we're going to talk about that other strategy we discussed. Is there a way for me to turn halves into 6? What can I do to a half to make it 6? Well, if I cut 1/2 3 times, I end up with what size pieces? 6. And so we had 5 6. The equivalent to 1/2 was 3. Remember, when we cut it into 3, that's the same as multiplying it by 3 over 3, because what I do to the numerator, I must do to the denominator if I want to keep them what? Equivalent. In order to keep them equivalent, you have to do the same thing. And so my model and my multiplication both shows me that the equivalent representation of 1/2 in the form of 6 is 3 6. Now I can solve this as well. 5 6 take away 3 6 is 2 6. Some of you may recognize that 2 6 can also be written as 1/3. Let me show you that using our original model where we X'd out. We were left with 4 and then another 4 there. And so I now, if I partition them this way, it's no longer 12 pieces, it is 1, 2, 3 pieces. And since I have this entire chunk, that is 1 out of 3 pieces. So 2 6 or 4 12 are also equivalent to 1/3. All of these are answers to the problem. How can 3 numbers be answers to the same problem? The answer to that is because they're worth the same value. They are equivalent fractions. So even though these 3 fractions look different, on my chart, I can see that they represent the same number. All right. Today we have practiced subtracting fractions with unlike units. You sure did a great job. After the video, you will have some problems to practice on your own. Good luck and do your best. If you do not have access to the student packet at home, please have your pencil and paper ready and jot down these practice problems. Your directions are to subtract the fractions using a strategy to create equivalent fractions. The first problem is 2/3 minus 1/2. Your second problem is 5 6 minus 1/4. And your third problem is 4 5 minus 1/2. Boys and girls, I enjoyed doing this mathematics with you today. Thank you for inviting me into your home, and I look forward to seeing you in the next lesson of Tennessee at Home Learning Series. Bye!
Hey, little man, do you know what these are called? What are these? What are these called? These are letters. Letters of the alphabet. And today we're going to play a game called Stomp the Letter, where we identify letters of the alphabet, okay? Let's start with the first letter of your name, Jaden. What does Jaden start with?
J.
Can you stomp on J? Show me. Stomp on J. That was a little tiny stomp. But that is J. J for Jaden. There it is. Let's do another one. Can you identify the letter F? That's right. Can you tell me a word that starts with the letter F? F for?
Fox.
Oh, fox. That's a good one. Okay, good. Let's identify the letter M. Can you stomp on the letter M?
The W.
When you turn around that way, it does become a W. That's right.
This is M.
And now it's an M again. Can you tell me a word that starts with M?
Ham.
No, what starts with M?
Monkey.
Monkey. Good job. You did a great job identifying the letters.